In this video, we're going to look at an exam question on pre-part contradiction. So how you lay out a pre-part contradiction question is you start by assuming that the opposite of the statement is true. So we're going to assume that the sum of two rational numbers is actually an irrational number, and changing that last bit of the statement makes it so that it's the opposite of a statement. Our whole goal now is to somehow disprove this assumption, because if you disprove it, that means that the original statement has to be true. It's either the original statement or the assumption that you made is true. It's either one or the other. So how do we disprove this assumption? Well, let's introduce two rational numbers and show that when you add them together, it's actually not irrational. So we can say let x equals a over b, and we can say let y equals c over d. So what makes them irrational? Well, it's the fact that a, b, c, and d are integers, all in their simplest form. So yeah, that is what makes a number rational. For example, 3 over 5, top and bottom are integers, and that makes it so that that whole fraction is a rational number. That also applies to 7 over 1, because top and bottom are integers, that's a rational number. However, if you have something like 5 over root 3, the top is an integer whereas the bottom isn't, so this is not a rational number. So that's how you define it in an exam, the integers in their simplest form. Let's now focus on adding these two together. By these two, I mean these two sort of rational numbers. So x plus y would be a over b plus c over d. And when you add fractions, you can use cross multiplication here. So you can do a times d is ad, c times b is cb, all over the multiplication of the denominator is bd. Once you've done that, because you've introduced a, b, c, and d as integers, a times d will be an integer, won't it? On top of that, c times b would also be an integer, because any two integers multiplied together would give you another integer. 5 times 7 is 35, another integer. Similarly, b times d would also give you an integer. That means that the top and bottom of the fraction ends up being an integer at the end of the question. However, that disproves the assumption, because our assumption is that when you add two rational numbers, it gives you an irrational, whereas we've shown that it actually gives you a rational. How you'd word that as like your final finishing statement of the question is, this disproves the assumption, so the original statement has to hold true. Or if you wanted to do it a bit of a longer way, you could say, so the sum of two rational numbers is always a rational number. Holds true. Perfect. Yeah, that's everything for this question. Be sure to leave a like if the video helped and subscribe. I'd appreciate it a lot. Thanks for watching. Thanks for watching the video, guys. Hope it helped. If you have any A-level maths or physics tutoring inquiries, be sure to send me a message at www.excellineducation.co.uk.